Hi everyone, my name is Salvador Lima-López. I am a computational linguist working at the Barcelona Supercomputing Center's text mining unit. Today I will be presenting a short overview of the MEDDOPROF Shared Task, which is about the detection and normalization of occupations in Spanish medical documents. MEDDOPROF was held as part of the IberLEF 2021 workshop, which in turn is part of the SEPLN conference. As you may know, the BSc's text mining unit has already celebrated multiple medical NLP shared tasks, mostly in Spanish in the past, such as CancerMist about cancer name entity recognition and normalization, or CODIESP about Spanish clinical coding, MESINESP about medical semantic indexing, and MEDOCAN about medical document anonymization. Today I will be presenting MEDDOPROF, which is our latest shared task. MEDDOPROF stands for Medical Document Profession Recognition, and it was organized by Eulalia Ferrer-Maduel, Antonio Miranda Escalada, and our head investigator Martin Kralinger on the BSc's part, and Vicente Briva Iglesias from Dublin University, as well as myself, Salvador Lima. Here is the task website in case you want to learn more about it. Well, why do we need a shared task about occupations? Why are occupations important? Well, the truth is that occupations have a significant impact in our health and lifestyles. Even since when we are children, we are constantly asked what we want to be when we grow up. And as adults, most of us probably get up early in the morning just because we have to go to work, right? This means that every choice and many of the things we do daily are a consequence of our occupation. And according to the International Labour Organization, every year there are more than 300 million occupational accidents and over 150 million victims of work-related illnesses. And this includes workplace accidents, exposure to toxic substances and pathogens, as well as work-related mental health issues, to name a few. In order to try to improve the situation, and to study a little bit the causes of these accidents and illnesses, there is a field within data mining, which is called occupational data mining, and it tries to build up and extract knowledge to do things that could improve workers' quality of life. However, this field usually uses structured data, and there is a lot of occupational data in an unstructured text that can be accessed, for example, in electronic health records or clinical reports, social media posts, etc. And there are not that many natural language processing systems that can detect and classify occupations to help this field. Because of that, we need to develop systems that are able to detect and classify these occupations. There are already some resources, but they mostly consider job titles, which is just one way of talking about occupations. But the truth is that natural language is much more varied than that. And we need to have some resources that actually characterize how people talk about occupations. And finally, these resources need to be high quality, right? And they should be able to be used for benchmarking. In this regard, we celebrated earlier this year the ProfNER Shared Task, which is also about occupation detection. It was held as part of the NACOL, or North American Association for Computational Linguistics conference, and the 6th Social Media Mining for Health workshop. ProfNER is kind of a sister task to MEDDOPROF, but instead of being focused on medical documents, it focuses on COVID-related social media posts in Spanish, specifically Twitter posts. If you want to learn more about the task, please visit this website. Well, this time we decided to focus on medical documents. Specifically, we annotated almost 2,000 clinical cases in Spanish and from around 20 different specialties, including COVID cases, dermatology, cardiology, psychiatry. This is important because the information in the different specialties is not always the same. Some specialties, such as psychiatry, contain much more occupational information than the average. Well, these clinical cases were manually labeled by experts with mentions of professions, activities, and working statuses. I will be going more in depth to that later on, and they were later classified according to their holder or referent. The final interannotator agreement of the corpus is around 0.9. In case you don't know, the interannotator agreement is a measure of quality and consistency of the data. And you can download the dataset from Phenom. Here is the link. I want to show you some examples just so you know how the corpus looks like on annotations. For example, this sentence, jornalero obrero en actividades agrícolas, cosechando legumbres en la zona de Iguerote, roughly translates to farmer, worker in farming activities, farming legumes in the Iguerote zone. Here we have some occupations that are really job titles, like farmer, jornalero, and then some which are a little bit more descriptive. But we also have some mentions that are really, really descriptive. For example, this one is expressed almost through a whole sentence, like, right? El paciente se dedica a la gerencia de un hotel familiar. The patient is dedicated to managing a family hotel. This is much more descriptive than just a single word, right? And an interesting detail is that these cases include information, not all of them, but many of them include some information about the problems that I described at the beginning of the presentation, such as mental health issues or exposure to substances. For instance, this case is about a patient who has anxiety problems and it's affecting their work. We also included some working statuses in a really broad sense. For example, we have some working situations, so to say, such as trabajaban desde el hogar, working from home. And we also have some more common working statuses, such as unemployed, desempleado, and some socioeconomic situations, such as in poverty conditions, condiciones de indigencia. In order to annotate the MEDDOPROF Gold Standard Corpus, we created from scratch annotation guidelines that describe how this topic should be approached. This is a picture of the guidelines, which are around 33 pages long, and there are over 70 rules and exceptions. Here's an example of what the rules look like. Yeah, they have like small title, an explanation, their link to other rules, and some examples that are color-coded. If you want to visit the annotation guidelines, maybe take a look at them, you can also download them from Zenodo. Okay, so when we started to work on this problem, we couldn't really find an occupation typology that satisfied us. Because there are multiple typologies, but none of them are really focused on a text mining approach, and specifically on a clinical text mining approach. So after studying some different resources, such as Dex, Mesh, SNOMED, we decided to create this occupation typology. On the one hand, we have these three occupation types. We have professions, which are paid occupations, for example, web developer, psychologist, and some which are more descriptive, as I showed earlier, such as work in a family business, a small hotel. We also have employment statuses, such as occupational and socioeconomic statuses. For instance, has finished secondary school, works from home, which I showed earlier, receiving no pay, mentions about being in prison, and there are also some mentions that are semi-structured, such as occupation home. And finally, we have activities, which are non-paid occupations, and they're mostly hobbies and similar stuff. For instance, playing the guitar, doing gardening, volunteering, etc. On top of annotating and creating this typology to distinguish different types of occupations, we also classify them according to their referent or holder. So we have occupations that are about the patient, occupations that belong to family members, occupations that are about health professionals in general, and then a category called other, which I think mostly includes police officer, judges, lawyers, and stuff like that. And we also normalized all of these occupations to standard terminologies. The first one we used was ESCO, which is the European Skills, Competences and Occupations Classification. And we also used SNOMED. I will go a little bit more in depth into this later on. So MEDDOPROF has 3 different subtracts. The first subtract is called MEDDOPROF-NER. It's about detecting different occupation types. So the 3 types that I just explained: professions, activities, and employment statuses. The second subtract is MEDDOPROF class, which is about classifying these occupations according to their holder into, as I just said, patient, family member, health professional, or other. And finally, a normalization subtract called MEDDOPROF Norm, in which these occupations had to be normalized to either the ESCO classification or SNOMED-CT. Okay, here are some corpus statistics. As you see, the final size of the corpus is 1,844 documents, and it has almost 5,000 annotations. The most common labels are, on the one hand, profession, and on the other hand, patient, as could be expected, but there are also many employment statuses, not that many activities, but there were really not that much. Okay, so I'm going to talk a little bit more about the normalization subtract. As you may know, an important part to ensure semantic interoperability is to make sure that we can match terms that have the same meaning to the same identifier in standard terminology. This is a task that is usually known as normalization or entity linking or entity grounding. It has many names. And we use 2 different terminologies for this: the European Skills, Competences, Qualifications, and Occupations Classification, ESCO, and SNOMED-CT. In case you don't know, ESCO is a classification created by the European Union that tries to identify and categorize skills, competences, qualifications, and occupations relevant for the European Union labor market, and also the relationships between them. So, for example, each occupation has a set of related skills. And this classification is based on the International Standard Classification of Occupation, ISCO, which was created by the International Labour Organization. Nowadays, ESCO is used by many institutions, and it's also a really large terminology classification. It's also multilingual. It's in many of the European Union's languages, and it's also very comprehensive. So because of that, we decided to use it. However, we have a lot of diversity in our data, in the sense that we also consider annotations and employment statuses. So we had to complement ESCO using another terminology, and we decided to use SNOMED-CT, as it's also very comprehensive and it's a fairly popular terminology. To summarize, we normalized most of the professions to ESCO, and to SNOMED-CT when we mapped some illegal occupations that we couldn't find in ESCO, as well as employment statuses and activities. Even then, it wasn't always easy to choose the best code for each mention, as there isn't really a comprehensive terminology that encompasses all of these 3 categories. And sometimes we had to choose codes that were a little bit related, but not exactly correct. For instance, for people who do yoga as a hobby, we had to use this SNOMED code, which is called participation in yoga as a regime or therapy. This necessarily gives the activity a medical association, and it doesn't have to be so. It can just be a hobby, right? Or a sport. Okay. So if you don't know what mapping is, I want to give you just a very short example. Assume we have these 3 terms: auxiliar de enfermería, aux de enfermería, and AXE. Well, mapping is about assigning them the same code because they have the same meaning. And in this case, their code would be the ESCO code 5321.1.1, which corresponds to nurse assistant. I just wanted to give you an example in case you didn't know what this was about. Okay, about the evaluation of the task, we used the precision recall and F1 score microaverage for all three of the subtracts. And for MEDDOPROF NER and class, both the span and label must be correct. It was a strict evaluation setting with 4 exact matches. So for instance, given the sentence, the patient worked as a courier, el paciente trabajaba como mensajero in Spanish, if the participants predicted como mensajero when the occupation is just mensajero, this is incorrect because the span is incorrect. And if they predicted mensajero but assigned the family member label, this was incorrect because the incorrect label, the label is incorrect, sorry. So what would be the correct annotation or prediction? Is only mensajero is predicted and its label is paciente. This has both the correct span and a correct label. Well, and for MEDDOPROF Norm, both the span and code granularity must be correct, as the participants also had to find dimensions. So the code granularity part is important because, for example, if someone predicted 4412 for this mention, it would be incorrect because in the gold standard, the code is a little bit more granular and it's 4412.2. So it was a quite strict evaluation setting. Okay, here is a list of some of the main resources we generated for the shared task. On the one hand, we have the gold standard corpus, which I explained earlier, and you can download from this link, as well as the MEDDOPROF guidelines, which, as I say, describe how to annotate and normalize occupations in a clinical setting, and you can download it from here. If you want to take a look at the taskis overview paper, it's on the SEPLN journal, and you can visit it for free. We also generated some additional resources. For example, we generated a complementary entities dataset, which is a version of the train set. This is a mistake, sorry. Which includes automatic annotations for diseases, symptoms, drugs and procedures, so some clinical entities, and some linguistic entities such as negation and speculation triggers and scopes. We also generated a occupations gazetteer by gathering terms from terminological resources such as DEX, ESCO, NumedCT, and WordNet, and some occupations that are detected by the Stanford Core NLP. You can also download it for free here. This is an example of the complementary entities dataset that I just mentioned. As you can see, there we have the occupations annotated. These are gold standard occupations, gold standard annotations, sorry, which were manually created, and then the rest of the annotations were automatically created. And we have some clinical entities and some linguistic entities. If you are interested, I invite you to take a look at it. And if you have any questions, don't hesitate to write. Okay. Now, I already explained the motivation behind the task. I already explained the data and the generated resources. I'm going to talk a little bit about the participation and the results. Well, overall, we had 40 registered teams. Out of which 15 ended up participating, and all in all they submitted 94 runs or systems. These teams are from 6 different countries, including India, the United States, and Germany, and the participants presented 8 system description papers. As for the results for each individual task, this is the results for the MEDDOPROF subtract. As you can see, the best performing systems are around 0.8, which is kind of close to the inter-annotator agreement. The baseline is 0.4. And I think both of these systems used some type of transformers. They have submitted participant papers, so if you want to learn about their methodology, I invite you to take a look at their papers. As for MEDDOPROF class, the results are similar to MEDDOPROF NER, but perhaps a little bit lower. The participation was also a little bit lower. And perhaps the reason behind the small drop in performance is that assigning a referent to each occupation is perhaps, well, it requires a little bit more understanding of the sentences in a semantic and pragmatic way. and perhaps current systems that they don't encode this type of information that well. Well, and as for the MEDDOPROF Norm subtract, the results were also quite acceptable, although not as high as for the other task. This is because the participants had to both detect the predictions and then try to assign a code to them. So this means that if they failed in the first part, there was some error propagation that could be seen in the normalization part. But as for the methodologies the participants used, as is the current trend in natural language processing nowadays, transformers were the most popular architecture. Conditional random fields were also very popular, and some participants also used some non-neural approaches. It's also noteworthy that I think all of the participants use some type of open source NLP software, such as spaCy, PyTorch, TensorFlow, Hugging Face, etc. If you want to learn more about the methodologies, please try to take a look at the participant papers, which are available at Seoul, also for free. And many of the participants also released their codes, so maybe you would like to take a look at them too. Here is the GitHub links. And to finalize, I want to talk a little bit about the complexity and the errors we found in the participant systems. First of all, we found that there is a lot of ambiguity, at least in Spanish, for this task, as many occupations and many of the more straightforward ones can be either nouns or adjectives. For example, the word clinical can mean either physician or clinical as an adjective. And the word mathematical can either mean a mathematician, a person, or it can mean mathematical. And there are many, many examples like this. Another complexity of the task is that there are some occupations that have similar structures to other type of information, such as empleado en carpintería metálica, employee in metalwork. This is an occupation per se, but for example, teacher in Ivory Coast, only teacher is the occupation and Ivory Coast is a location, right? And the predictions sometimes were a little bit too long and included this type of information. Next, many of the mentions were in some way indirect. For example, there is this semi-structured information, work history, aluminum factory. So this is very indirect, occupation home. And there were also some abbreviations. And these are much more difficult because you have to know what the abbreviation means in order to be able to detect it, right? So, for example, treated by the PCP, which means primary care physician. Another important complexity of the task is that some occupations can be standalone occupations, so to say, or they can be a little bit more specific. So for example, we have both engineer and civil engineer, and some participants systems, they only predicted the main occupation, so to say. For example, if they only detect engineer and the whole mention is civil engineer, their prediction would be incorrect given the strict evaluation setting. As for the normalization, one of the main difficulties that we encountered, and it could also be seen in the participant systems, is that the code granularity, especially for ESCO codes, was sometimes a little bit hard to distinguish, because many of the codes have similar or directly the same name, right? For example, all of these three codes are called Commissioned Armed Forces Officers. Well, just to summarize a little bit what I just said, for the MEDDOPROF shared task, we had participants from 17 different countries, which registered in a shared task about occupation detection and normalization in Spanish documents. We generated a corpus of 1,844 documents, annotated with professions, employment statuses and activities, and then normalized. We had a scientific committee who really helped us, which contained 13 members which are from the research field, 1 from industry, and 3 clinical authorities. So we had to try some cross-disciplinary community involvement. And it's also noteworthy that almost 100% of the participants use machine learning, and more specifically deep learning. Well, as for the future steps we would like to follow, the first one is that, well, even though we had some competitive results given the reasonably small data set, we would obviously like to expand the annotated data, maybe include some other type of occupational information. I don't know. Our original goal was to annotate 2,000 documents, but because of some difficulties in the annotation, we were a little bit below that. So we would like to at least reach those 2,000 documents. We would also like to explore the application of this type of information extraction to electronic health records, along with other social determinants of health, as well as to other domains and languages. And given that the terminologies we use for normalization are multilingual, applying it to other languages might be kind of easy. Not really easy, but having multilingual terminologies will actually be helpful. And finally, we would also like to explore the creation of an ensemble system using the systems generated by the participants to see if we can have like one massive system that is the gold standard system, so to say. Okay, I think that was all for now. I just want to finish by giving thanks to the IberLEF 2021 organizers, in special Paulo Rosso, Manuel Montes, and Julio Gonzalo, and of course all the participants and people who registered for the task. I also want to thank the Plan de Tecnologías del Lenguaje from the Spanish government and the Minister of Science, because they funded the project. Next, I want to thank my teammates from the BSc Text Mining Unit, Martin, Antonio, and Eulalia, as well as Vicent, who from Dublin University, who also worked with us in this project, and everyone in the scientific committee. But that was all for now. Here is like a bit overview of the whole task. I hope you like the presentation, and if you have any questions, would like to collaborate with us, or I don't know, just want to talk about the task, please don't hesitate to write to me to this email and visit our website. Thank you.